All right, today we're going to trace the connections, the really intricate connections of our planet's climate system. We're going to follow a chain reaction that kicks off in the absolute coldest parts of the world and ends right in the heart of South Asia. It's like a giant planetary domino effect.
So here's a question for you. It might sound a little like a riddle, but honestly, it's the central question for understanding our world right now. What does a melting glacier way over in Antarctica have to do with a river flowing through India? I know, they seem totally disconnected. But stick with me, because by the end of this explainer, I promise, the answer is going to be crystal clear.
Okay, before we dive deep, let's get our foundation right. Just to make sure we're all on the same page. When we say climate change, what are we really talking about? We mean these really big, measurable shifts in weather patterns that happen over a long time. It's basically the warming of our planet, and that's what's kicking all these other dominoes over.
So every chain reaction has to start somewhere, right? A first domino. For our planet, that first domino involves some huge, pretty dramatic physical changes. You could think of it as the planet's rising fever.
And here's a number that, well, it's pretty shocking. The rate of ice loss in Antarctica, it's tripled. And that's just in the last decade. So, it's not just that it's melting anymore. The whole process is speeding up at an alarming rate. And that acceleration, that's what really has scientists worried.
So where does all that water go? I mean, it has to go somewhere, right? It goes straight into the ocean, and that, of course, makes sea levels rise. But believe it or not, that's only half the story. The other part is that as the ocean itself gets warmer, the water, it literally expands. It's a thing called thermal expansion. So we're getting hit with a double whammy. More water from the melting ice, and the water that's already there is getting bigger because of the heat.
Okay, now we get to what is maybe one of the most dangerous cycles in this whole thing. Up in the Arctic, you have these huge areas of what's called permafrost, basically ground that's been frozen solid for centuries. Well, it's thawing. And as it thaws, it releases methane gas. Now, methane is a greenhouse gas that is way more potent than CO2. And that methane, well, it speeds up the warming, which, yeah, you guessed it, thaws even more permafrost. It's a terrifying, self-perpetuating feedback loop.
Now these huge physical changes, they don't just happen in a vacuum. It's like throwing a giant rock into a still pond. The ripples go everywhere. They're triggering a whole world of change, affecting the planet's core operating systems. We're talking about the oceans, the weather, and pretty much all the life that depends on them.
For a long time, our oceans have been doing us a massive favor. They've been acting like a giant sponge, soaking up a huge amount of the CO2 we've been pumping into the air. But there's no such thing as a free lunch. When all that CO2 dissolves in seawater, it forms carbonic acid, and that is literally making the entire ocean more acidic.
And, you might be thinking, so what? A little more acidic, what's the big deal? Well, it's a huge deal for marine creatures like corals, shellfish, and even tiny plankton. See, they build their shells and their skeletons out of a material called calcium carbonate. And in more acidic water, that material starts to dissolve. It's like their armor is weakening from the outside in. This is a massive threat that could unravel entire food webs from the very bottom all the way up to the fish that end up on our plates.
All right, let's talk about the weather, because climate change isn't just about turning up the global thermostat a few degrees. What it really does is take our existing weather patterns and puts them on steroids. And one of the clearest things we see from the models is this. The dry parts of the world, they're just going to get drier. We're talking more frequent, more intense droughts.
And yeah, the flip side is just as true. The places that are normally wet, they're going to get wetter. Think more extreme rainfall, more flooding. So if you take one thing away about the weather, it's not just the word warming, it's the word extremes. Everything is becoming more volatile, more unpredictable, everywhere.
And it's not just us, of course. Animals and plants are feeling the heat big time. We're actually witnessing a massive migration happening right now, as different species are literally on the move, trying to find climates they can survive in. They're heading toward the poles or climbing higher and higher up mountains, just looking for cooler air. It's like this silent, planet-wide reshuffling of life as we know it.
Okay, so this all brings us to the most crucial point, really. What does all of this mean for us, for people? Because this isn't just some abstract environmental story. This is a human story. It's about our health, our food, and ultimately, the stability of our societies.
And our health is on the line in ways you might not even think about. As the planet gets warmer, so do the places where disease-carrying insects can live. We're seeing mosquitoes push into totally new territories.
For example, malaria is now showing up in high-altitude places like Nepal and Bhutan, areas that have historically been way too cold for it to ever be a problem.
And it's not just diseases from insects, not by a long shot. The threats are coming from all sides. More intense heat waves mean more heat-related deaths, floods and droughts. They contaminate our water supplies. Even damage to the ozone layer means we're getting more exposure to harmful UV radiation. It's really a full-on assault on public health.
Think about it. When a drought wipes out a year's worth of crops, or a flood washes away an entire town, that's when social stability starts to crack. There's a term security experts use. They call climate change a threat multiplier. And all that means is that it takes existing problems like tensions over food or water and just makes them worse. This can lead to conflict, and it forces people to pack up and leave their homes, creating environmental refugees.
Okay, so now let's bring all these threads together. Let's zoom in and focus on one country that is sitting right at the intersection of almost all of these threats: India. This is where you can really see that global domino effect hitting home, and with incredible force.
So, people often call the Himalayan glaciers the third pole, and there's a really good reason for that. They are essentially a gigantic freshwater reserve for something like 1 billion people. But they are melting, and they're melting fast. This isn't some far-off, distant problem. For regional water security, it is a ticking clock.
And this creates this really cruel paradox. See, in the short term, as the glaciers melt faster and faster, they pour water into rivers like the Indus and the Brahmaputra, causing terrible, devastating floods. But in the long term, once those glaciers are gone, that's it. The rivers will shrink, leading to just dire water shortages. So they're facing this future of too much water followed by not nearly enough.
And the threat isn't just coming down from the mountains. It's also coming in from the sea. You take two of India's biggest, most important cities, Kolkata and Mumbai. These are massive coastal megacities. They are incredibly vulnerable to rising sea levels and to bigger, more powerful storm surges.
I mean, the list of challenges that India is facing, it's just staggering. The summer monsoon, which is the absolute lifeblood of their agriculture, it's becoming completely unpredictable. Droughts in the northwest are getting worse. Along the coast, salt water is seeping into freshwater supplies, contaminating them. And then, way up in the Himalayas, you have these unstable lakes forming from the glacier melt that can just burst without any warning, unleashing what they call glacial lake outburst floods, or GLOFs, which are just catastrophic.
So, let's zoom back out for a second. When you do, the picture becomes incredibly clear. We don't live on a planet where things happen in isolation. We live in one single, deeply, deeply interconnected system.
The dominoes really do fall from the pole all the way to the equator. That ice that melts in Antarctica, it directly contributes to the water lapping at the streets in Mumbai. The carbon that's released in one hemisphere makes the ocean more acidic in the other. Every single one of us is part of this one single planetary chain reaction.
And that brings us right back to our final and most critical question. We've connected the dots, right? All the way from a melting glacier to an Indian river. We've seen how local impacts have global causes. So, if that's the problem, what does that tell us about where the solutions have to come from? That's the thought I want to leave you with.